Welcome. Suppose you roll one six-sided bear die. Find the probabilities of the following events. Event A is the upper face is a 3. So the probability of A, and actually I'm going to quickly write up our sample space here. Our sample space when rolling one six-sided die is 1, 2, 3, 4, 5, and 6. Those are all the possible outcomes. So as you can see, having the upper face of our die be 3, there is one way for that to occur out of 6. As a decimal, this equals 0.1667. Next, let's look at part B. In part B, we're given the event B. The upper face is a 4. Now again, this is just going to be 1 out of 6 since there's only one 4 out of 6 total outcomes. Next, let's look at part C. Part C, we want to find the probabilities, or excuse me, the probability that A and B occur simultaneously. Well, let's consider rolling our die one time, and I only have one. What is the probability that I'll see both 3 dots and 4 dots on the upper face? Well, clearly it's 0. Excuse me. Clearly that probability is 0 since it is not possible to roll one die and simultaneously get 2 faces to be on top. Part D, let's find the probability of A or B. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, from this previous part, we know that A and B are mutually exclusive. There are no outcomes in their intersection, so the probability of them occurring together is 0. They cannot occur together. They are disjoint, so I can just write a 0 here. That's 0. So really, I just need to add up 1 over 6 plus 1 over 6 to get me 2 over 6. And this is the probability of A or B, and that's equal to 1/3. And that's 0.3333. Going to quickly make a little more space for the next side. Let's move on to part E. Event C is the upper face is odd. So what is in C? We have 1, 3, 5. Those are the only odd possibilities. So the probability of C is equal to 3 successful outcomes out of 6 possible, and that's 1/2. As a decimal, that's 0.5. Next, part F, are A and C mutually exclusive? So remember, A is the upper face is a 3, C is the upper face is odd. They have something in common. That is, A intersect with C, A and C has the element 3 inside. So I know the probability of A and C is equal to 1 out of 6. Since it's not equal to 0, these are not mutually exclusive. We could have also stopped here when we identified that they share an element in common and avoided this and just written they're not mutually exclusive since they can occur simultaneously. I will add that. Next, let's look at part G. Are B and C mutually exclusive? So B is the upper faces of 4, and C is the upper faces odd. Since it is not possible to both get an odd face and a 4, they have no elements in common, notice. These are mutually exclusive. So B and C as a set would look like this with nothing in them. You could also denote this with this empty set symbol. This, however, is not required for this course. But what you do need to know is that the probability of these events, as they are disjoint, that is, they're mutually exclusive, is 0. So these events are mutually exclusive, as they cannot occur simultaneously. I hope you found this video helpful.